Morning, afternoon, evening, forever you're watching. You're welcome back once again to the Mickey Mouse Class, a channel so dedicated to demystifying mathematics, making complex problems look easy. Come along, what do we have today? We have the cone. This is an example of a cone. This is a cone. It's a solid shape that has a circular base and a pointed end. So you see this cone here, it has a curved body. Now let's draw it on the board. These are the example of a cone. Let's label it. This is the cone. This is the vertex, the pointed end. This point is the vertex. The pointed end is called the vertex. Now, this here is the slant height. This is the height. Slant means something slipping or bending over. Let me put it that way. Slant height of the cone. This is the circular base. Circular base. And of course, since this is a circle, it has from here to here this is the radius of the cone, of the circle rather. The radius of the circle here. Now from here, from the vertex up to this point is the height. So this is the height of the cone. So we have ended up naming the cone. Okay, let's look at some formulas relating to cone. The first one is the curved surface area. Number one, the curved surface area. Let's use the CSA. Curved surface area of cone is given by pi RL. The L here, the slant height, can be written as L. That's the slant height of the cone. Now, the curved surface area, this is the formula for curved surface area of a cone, pi RL. The second one, you can be asked to find the total surface area, TSA, of the cone. The total surface area is the area of this base here, the circular base plus the curved surface area, the CSA. So the area of this is pi r square. So that's pi r square plus pi RL. So what's common between these two? We have pi r, we can factorize it. So this becomes pi r into bracket r plus L. So the total surface area of a cone is given by the formula pi r into bracket r plus L. Now, the third one, the volume of a cone is given by the formula 1/3 pi r square h. That's the volume of a cone, 1/3 pi r square h. And lastly, you can be asked to find the slant height of the cone. Slant height. Now look at this. This is the slant height L. This thing forms a right angle triangle. It forms a right angle triangle. I can bring it out like this. It forms a right angle triangle. This is the slant height L. This is the height here H. And this is the radius R. So from here, we can use Pythagoras theorem to find the slant height. And Pythagoras theorem says that hypotenuse square, that's L square, equals to opposite square, that's H square, plus adjacent square, R squared. That's what Pythagoras theorem says. So from here, we can make L subject of the formula. So this becomes, take the square root of both sides. So this becomes L square, take the square root, is equals to square root of H square plus R squared. Square will cancel square. Therefore, our L, our slant height, is equals to square root of H square plus R square. So these are the basic formulas you need when you are dealing with calculation under cone. All right, let's look at this question. It says a cone has a base radius of 6 centimeters and the height 9 centimeters. Calculate the first one, its volume, the curved surface area, and the total surface area. So let's look at our solution. Okay, so the first one, let's bring up our parameter, or let's draw the cone. Make a sketch of the cone here. That's the radius. That means from here to here is 6 centimeter. This is the height, is 9. We are not given the slant height, so we put as L. Calculate its volume. The first thing, we know that volume of a cone, volume is equals to 1/3 pi r square h. And we already know that our radius here is 6. Our height, 6 centimeter. Our height is 9 centimeter. So we impute it into this. So the volume is equals to 1/3 times our pi. We use 22/7. 22/7 times the radius is 6 square, times our height, which is 9. Okay, so from here, 6 square is 36. So 22 times 36 times 9 will give us 7128 over 7 times 3 is 21. So when we divide that by 21, we'll get 339.43 centimeter cube. So that's the volume of the cone. The B part says that we should calculate the CSA. That's the curved surface area. The curved surface area of a cone is given by the formula pi RL. That's the curved surface area. So from here, something is missing. That's our L, which was not given in the question, so we have to find it. We use the Pythagoras theorem to find it. Our L is equals to the square root of our h squared plus our r squared. So our L will be equals to square root of our h squared, that's 9 squared. 9 squared plus our r is 6 squared. So our L will be equals to 9 square is what? That's 81 plus 6 square is 36. Okay, so 81, that's 117. That's 36. Our L will be square root of 117, which is equals to 10.82 thereabouts. Square root of 117. Yes, that would be 10.82, of course, in centimeter. Now, having found what our slant height is, let's plug it into the formula for CSA. So our CSA becomes our pi 22/7 times the radius. The radius is 6 times 6 times the slant height, 10.82. So when we multiply it, we'll get 22 times 6 will give us 132 times 10.82. That will give us about 1428.24 over 7. So when we divide that by 7, we are going to get 204.034, of course, centimeter squared. So that's the curved surface area. Last but not the least, the total surface area. So our TSA is equals to pi r into brackets. Let's put this here. Pi r into bracket r plus our L, the slant height. That's the formula. Then from here, our pi is 22/7. Let's plug it in. 22/7 times our radius is 6 into bracket 6 plus 10.82. 10.82. So let's calculate. So 10.82, when you add it to 6, that's 16.82 times 6 times 22. So this will give us about 2220.24 all over 7. So when we divide that by 7, we are going to have 317.18, of course, centimeter squared. So that is the total surface area of the cone. All right, I hope you have learned in today's class. We looked at a cone. We looked at what it is. It's a solid shape that has a pointed end with a circular base with a curved side to it. And we looked at the various formulas for cone, solving the volume of a cone, the curved surface area, the total surface area. All right, just like in our usual style, before we go, here some list of take-home fun. You can practice at your leisure time. The first one says, find the total surface area of a solid circular cone with base radius 3 cm and slant height 4 cm. The second one says, the volume of a cone of height 9 cm is 1848 centimeter cube. Find its radius. Take pi to be equals to 22/7. The third one says a cone is 8 centimeter high and has a base diameter of 12 centimeter. Of course, you know that you cannot use this 12 centimeter. The diameter is or the radius is diameter over 2, so you have to divide this by 2 to plug into the formula. Find its slant height. Let me know the answers in the comment section. And if you enjoyed today's class, why not give us a like, give us a share, tell your friends about the Mickey Masters, a channel so dedicated to demystifying mathematics, making complex problems look easy. And if there's any aspect of mathematics you are struggling with, put in the comment section and I'll be there to attend to you. If you're here to subscribe, please kindly hit the subscribe button, turn on the notification bell so you don't miss out on wonderful content on the channel. To meet again in the next Mickey class or segment. Keep practicing. Remember, mathematics is fun. See you at the top. Shalom.